part 7 ng lecture natin, lecture 3, Cost Concepts and Design Economics para sa course na Engineering Economics. I-discuss natin ngayon yung present economy studies. When alternatives for accomplishing a specific task are being compared over 1 year or less and the influence of time on money can be ignored, engineering economic analysis are referred to as present economy studies. So kapag daw yung analysis natin, i-cover niya lang is 1 year or hindi natin kino-consider yung time value of money na i-discuss natin sa next lecture. So yung analysis doon is yung present economy studies. Kumbaga hindi natin i-consider kung mag-increase ba or magdi-decrease yung value ng money over time. So kung ano lang yung value niya sa taon na to or dun sa time ng analysis, so yun lang i-consider natin. So meron tayong dalawang rule. Rule 1, when revenues and other economic benefits are present and vary among alternatives, choose the alternative that maximizes overall profitability based on the number of defect-free units of a product or service produced. And then rule number 2, when revenues and other economic benefits are not present or are constant among all alternatives, consider only the cost and select the alternative that minimizes total cost per defect-free unit of product or service output. So, meron tayong dalawang rule na pwedeng i-consider. Kapag yung revenue is present, ang pipiliin natin kung ano yung alternative na bibigay ng maximum profit. And then yung isa naman, kapag hindi sinabi yung revenue or other economic benefits, ang pipiliin natin yung mag-minimize ang total cost. So ang goal natin, maximize yung overall profitability and then minimize natin yung total cost. Considering yung mga number of defect-free unit of product. Next, total cost and material selection. In many cases, economic selection among materials cannot be based solely on the cost of materials. Frequently, a change in materials will affect the design and processing costs, and shipping costs may also be altered. So, sa paggagawa natin ng isang product, pagde-design ng product, pwedeng mabago yung cost natin. Depende kung ano yung material na gagamitin. So, yung depende rin dun sa material na yun kung yung bang design process mo is tulad pa rin or may iba dahil ibang klaseng material yun tsaka yung pagpaprocess sa kanya. So, yung shipping cost ganun din. So, hindi nakabase lang dun sa presyo ng material yung gagamitin mo. Syempre, yung overall na effect niya dun sa design at saka sa production process at saka sa operating process. Gaya na discuss last time, yung i-consider natin syempre yung sa life cycle. Pwedeng depende dun sa material na gagamitin. Yun yung first example natin. So example number 1, annual demand is 100,000 units. The part is produced on a high-speed turret lathe using 1112 screw machine steel costing 30 cents per pound. A study was conducted to determine whether it might be cheaper to use brass screw stock costing $1.40 per pound because the weight of steel required per piece was 0.0353 pounds and that of brass 0.384 pounds. The material cost per piece was $0.0106 for steel and $0.0538 for brass. However, when the manufacturing engineering department was consulted, it was found that although 57.1 defect-free parts per hour were being produced by using steel, the output would be 102.9 defect-free parts per hour if brass were used. The machine attendant is paid $15 per hour and the variable or traceable overhead costs for the turret lathe are estimated to be $10 per hour. Which material should be used for this part? Sa problem natin, kailangan daw natin ng 100,000 units ng isang ng parts. So yung part na yun, pwedeng ang gawa siya sa steel or brass. So yun yung option natin for material use. So nakita rin na yung presyo ng steel per pound is 30 cents lang compared dun sa brass na $1.40. So mas mura siya kung material lang yung pipiliin mo. Kaya lang nakita rin na mas mataas pala yung output ng brass na 102.9 defect-free parts per hour compared sa 57.1 defect-free parts per hour ng steel. So, i-consider natin yung lahat ng factors na pwedeng maka-affect doon sa cost. So, hindi lang yung material cost per unit. So, i-solve natin. Kailangan daw natin ng 100,000 units. Halagay lang natin dito. So, denote na lang natin yan as N is equal to 100,000. And then, meron din dito na yung cost per pound. So, lagay natin dun sa Denote lang natin as steel. Ang cost niya is equal to 30 cents per pound. Tapos, material cost per piece. So, cost per piece, lagyan lang natin. So, 0.0106 dollars per piece. Then sa brass, so yung cost niya is $1.40 per pound. And then, yung cost per piece ng brass is 0.0538 per piece. So, ginawa dito hanggang 4 decimal places dahil yung i-relate natin siya dun sa 100,000 units. Labor, tulad naman sila. Ay, next pala yung weight natin per piece ay 0.0353 pounds per piece. Yung weight nito okay. So, ang next naman, yung labor, tulad lang sila. Mga $15. Ito yung variable overhead cost. Equals $10 per hour. So, meron din tayo yung output nila. So, yung output for steel equals 57.1. Or pwedeng sabihin natin na per hour or in 1 hour, ang puproduce ng steel is 57.1 piece. In 1 hour, napoproduce ng brass na defect-free parts ay 102.9 pieces. Okay. So, kunin na natin ito. So, para sa steel, so pwedeng i-relate natin na variable cost lang dahil or variable cost per piece. Yung kukunin natin for steel. So, variable cost so equal dun sa material na 0.0106. Ito ay per piece. So, dollars per piece. So, yung magiging unit dapat natin. So, cost per unit plus for labor na $15 per hour. And then kung ilang pieces yung magagawa niya. Yung magagawa niya per hour. Yung sa variable cost. So, ganun din. No? In 1 hour, meron kang 57.1 na defect-free parts. At yung para sa brass, so per unit, $15 per hour. In 1 hour, ang mapoproduce niya naman is 102.9. Over 102.9 pieces. So dito maka-cancel lang yung per hour. Solve natin. So balikan natin yung tanong. Which material should be used for this part? So based dun sa sagot natin, yung variable cost per unit ay 0.4489 per piece. Para sa bronze, 0.2968. So ang pipiliin natin dyan, syempre yung mas mura.